Um, I thought you might find this interesting because I did a bit of an investigation about Python variables, and it's kind of fascinating how it works. First, I didn't know why the hell it works the way it does, um, but it does work kind of strangely. And basically, if you have a variable that's like a number, okay, like in any other language, if I were to do a equals 23 and b equals 11, it would basically assign this to a fixed memory location, okay? In other words, you'd have to declare it as an integer in this case, or it could be a float, but I mean, in this case, you'd probably use an integer. Um, but in any event, it would keep it at a fixed location. Well, it doesn't work that way in Python, so it actually moves it around, just like you can see in this thing here. Um, it basically will, you create a variable, okay, and it assigns an initial default location, but then if you change the value of that variable, it actually moves it to a new location. It frees up this previous location, but it moves it to a new one. And then if you assign them to being equal, or even if you just assign them to the same value, they'll actually point to the same memory location. And but then it will, I guess, start over or whatnot if you go forward. But in any event, yeah, I made this program that kind of follows along that trajectory to analyze what's going on there. And you can see that these are the memory locations that I'm printing out in my little program, using the ID function. So, it's showing you that, okay, we had assigned A, equals 55. Where the hell is that happening at? Okay, yeah, A equals 55 here. Why isn't this? Okay, yeah, right here. Okay, so yeah, it starts 23, and then 11. So it's printing out the value and the initial addresses, and I'm also showing the address of that string, just for shits and giggles. Kind of see how these things hop around over it in memory. Anyway, then when I'm reassigning the value A, and you can see that A's memory location has changed. So in any other language like C or what have you, the memory location would be fixed. I mean, you'd never see them jump around like this, and because I mean that's chaotic. I mean, I can't imagine trying to track this damn thing with a pointer or whatnot if I needed to access it for other reasons, like in a different language. Um, but in any event, then we come down here and assign it to 11. So like I said, I've assigned it to 11 independently. I've said A equals 11, but guess what? It's got the same address as B now. And then I basically come down here and put A equals B, and they still have the same address. So, and of course, I did the same thing with the string. I reassigned that string here, from good to Fred, so it's the same number of characters. And again, in another language like C++, it would still keep the, since the strings would be the same size, it would still keep the same memory location. But typically, but here it changes it. So, and then we continue on with our program here. Okay, and I go investigate this specifically. I basically go ahead and set A, equal to a float. So A is a float now, or A equals 3.5, B equals 11. I'm using kind of Python syntax here, and then A times B equals, again, this value. So, again, we start out with this value, picking up where we leave off up there. So, so at first it's an integer. Now one of them is a float. Okay, but next, I go reassign B or A equal to a string, which you can see here, And now this multiplication, um, is treated, like, because I'm doing the same exact operation on all of these, but it's treated like a string, so it's, making multiple copies, and then, we're assigning it to a Boolean, okay, and that's the result. B is 11, so I guess B times true is, 11. B times false would probably have been 0, I assume. And then now I get it back to an integer by assigning the value 17 to it. So anyway, that's the reason it does that, though, because these are, it is bona fide, in the fact that it's being changed. You can look at some languages like, if I recall correctly, I think like JavaScript, for example, it's kind of similar in the sense that you don't have to officially declare variables. In fact, I don't even think you can, because everything's just a var, right? But the fact of the matter is that you can dynamically reassign the variable types, if I recall correctly. But what it does is it just converts them all to strings, or at least it does if they're in an array. I know that. So at first in JavaScript, it looks like you got an array that can store multiple data types all at the same time, but they can't. It just really converts them all to strings. So, which kind of puzzles me a little bit as to why because it looks like you could store functions in arrays too. Maybe you can, but because it's an interpreted language, JavaScript, if you stored a function in an array, it looks like you could execute it because, again, it's all parsing it out anyway. So, it's all text to begin with. That's how it treats it. It's an interpreted language. So, why would it have a problem with that? Looks like you could store all kinds of shit in there. But in any event, it stores it all as strings. But here it actually does change the type. And that's why the values jump all over the place, as far as their memory locations. That's why they change, because there is a chance that every time you change the number, it could change the type of the variable. And that's why they do that. They just do that as part of the fundamental operations of it, even though technically, it seems like a bit of a waste of time. And again, it would be a nightmare if you're trying to track this thing with pointers. But the fact of the matter is that, having it jump around like that is actually pretty beneficial. Like I said in one of these notes, it seems like it'd be good to, help confuse hackers, because they kind of rely on things being at a fixed memory location a lot of times, like passwords and things. You can kind of trip them out, if you actually kind of use that to your advantage, because it'll be like a random memory location. They might have a hard time figuring it out. I don't know. But in any event, if they're trying to monitor your password or what have you, or how to monitor for your code word in your program, so that they can try to get around your security, but it's just interesting, that's why they jump around like that, because that way they can dynamically reassign the length, so the downside is that even if it's the same type, it's still changing the memory location. But the upside is that you can dynamically change the type, so it can go from being I don't know, 4-byte value to a 400 byte value, from one iteration to the next, and still have it be the same basic label, the same basic variable. So anyway, I just thought that was kind of intriguing, but bizarre, but intriguing.